Yeah, so question 4 is saying a block of mass. Guess this should be 5.8 kilograms because I'm noticing the 5 in front here is almost everywhere. Okay, so a block of mass, 5.8 kilograms, is put up an incline or 25-degree incline, as in figure P4.24, with a force of magnitude 32 newtons. Find the acceleration of the block if the incline is frictionless. And question B, find the acceleration of the block if the coefficient of kinetic friction between the block and the incline is 0.10, like that. So this is an inclined plane or inclined motion, which means we're going to draw our diagram like that. We have a block here of mass. So we have weight pointing in that direction. Then we have 25 degrees, that's the theta there. I guess that's the data that we've been given. Then we have the mass of the block as 5.8 kilogram, and the force which is pulling this block as 32 newtons. So that's the only information we need. So we have mass. I'm going to draw my mass here as 5.8 kilograms. Then we have our force, which is pulling this block going up, which is equal to 32 newtons. Okay, so since this is an inclined plane, first things first, we're supposed to resolve our forces that are acting on this particular incline. So we're going to have our component there of y, and this is also equal to theta, which means the y component is adjacent to the theta. So I'm going to say this is mg cos c 25 degrees. And we're going to have another component which is away from the theta, which is mg sine 25, like this, 25 degrees. Then we also have a normal force there, which is Fn, like that. Okay, so they've asked us to say we should find the acceleration of the block going up if the surface of the, or if the surface is frictional. So what are we going to do? We're going to say summation of forces using Newton's second law. Summation of forces in the x will be equal to what? Will be equal to mass multiplied by acceleration. What forces do we have in the x? We have this force which is pulling this object, and this force which is opposing motion. So I'm going to say F, which is the positive force, minus mg sine 25, since the mg sine 25 is opposing the direction of acceleration. This will be equal to mass multiplied by acceleration, like that. What are we looking for? We're looking for acceleration of this particular block going up. Okay, so I'm going to say, okay, mass multiplied by acceleration, like that there. Then what else do we have? We know our mg. So I'm going to say my 32, which is the force, minus mg is 5.8 multiplied by 9.81, like this, sine 25 degrees. This is going to be equal to 5.8 multiplied by acceleration, like that. This is what we have in the x-axis. So let's simplify the equation further. We're having 5.8, or rather 5.8 multiplied by 9.81. This is 56. Okay, so that answer, sine 5.8 multiplied by 9.81 sine 25. So this is giving me 24.04. So I'm going to have 32 minus 24.05 being equal to 5.80, like this. Okay, then we can subtract 32 minus 24.05. This is giving me 7.95. 7.95 being equal to 5.80. So I divide both sides by 5.8, even this side by 5.8, like that. This will cancel out. That means my acceleration is equal to what? It is equal to 7.95 divided by 5.8 rather. So our acceleration on a frictionless surface will be equal to 1.37 meters per second squared. So that is the acceleration on a frictionless surface. This was question A. Let's now go to question B. On question B, we're going to use the same approach, but the only difference is that on part B, there is friction of, or there's a coefficient of friction which is equal to 0.1. So here they've introduced mu k, which is equal to 0.1. So the same thing is going to apply. It's just that under these circumstances, we're going to have an extra force opposing the direction of motion, and this force is the force of friction. So I'm going to introduce my formula to say the summation of forces in the x-axis will be equal to what? Will be equal to mass multiplied by acceleration. What forces do we have in the x? We have 32, which is F, the positive force, minus mg sine 25 minus the force of friction. This should be equal to mass multiplied by acceleration. F minus mg sine 25 minus mu k multiplied by normal force, which is Fn. This will be equal to mass multiplied by acceleration, like this. Okay, so the question is as simple as that. So I'm going to say my 32 minus mg sine 25. I had calculated this in the previous question. Where is it? Mg sine 25 is 24.5 or 24.05. So minus 24.05 minus mu k is 0.1 multiplied by the normal force. And what is the value of the normal force? If we look at our forces in the y-axis, these forces are at equilibrium. There is no acceleration in the y-axis, which means the forces in the positive y-axis are equal to the forces in the negative y-axis, which means the normal force is actually equal to mg cos theta. So I'll say multiplied by mg cos theta, and our mg cos theta is equal to 5.8 multiplied by 9.81 cos 25. This is going to be equal to mass multiplied by acceleration, like that. So let's find our mg cos theta. 5.8 multiplied by 9.81 cos 25. So this is 51.57. I'm going to say 32 minus 24.05 minus mg cos theta multiplied by 0.1. So it's giving me 5.16. This will be equal to 5.8 multiplied by acceleration, like this. So 32 minus 24.05 minus 5.16 rather, 0.16, this is equal to 2.79. So 2.79 is equal to 5.8. Hey, we divide both sides by 5.8. 5.8, this will cancel out. That means our acceleration when there's a kinetic friction, or when there's a coefficient of kinetic friction of 0.1, will be equal to 0.48 meters per second squared. So that is the acceleration when there's a coefficient of friction. Thank you very much. That was the end of question 4.